Hello everybody, welcome to my new programming club. Today we will solving another daily Leetcode challenge, and the challenge name is maximum number of events that can be attended, part 2. So here you are given an array events where each element in the events array is of the form start day, end day and value. So each element in the events array represent a event whose start day, end day and the value if you attend this event is given. So you are also given an integer k, which is a limit of maximum number of events that you can attend. So you further constraints are given. You can attend one event at a time. If for example, let's say this is the example, and you have decided to attend this event, you cannot be attending these two events simultaneously because they have some overlapping part. Okay, I hope this is clear. And then it's saying if you choose to attend an event, you must attend the entire event. So if you choose to attend, for example, the event with value 4, you cannot leave in halfway or any time before the end day. You have to completely attend the event. Okay, then note that the end day is also inclusive. That is, you cannot attend two events, one of them starts and one of them ends. So here it is saying, if let's say you decide to attend event with value 4, so it's ending at day number 2, this is the end, and another event with value 1 is starting at day number 2, you cannot attend these two one after another. So this is what the problem statement is telling. And then we have to return the maximum sum of values possible following these constraints. What are the constraints? That k is the maximum value of events that you can attend. You have to attend the event. Then you have to attend the entire event. If you decide to attend the event, you have to attend the entire event, and you cannot attend two overlapping events. So only one can be attended at a time, and the end is also inclusive. So for example, here one was ending at the second day and another was starting, so you cannot attend one after another because the end is inclusive. So we have to return the maximum sum of the values that we can achieve following these constraints. Let's have a look at the input constraints. So the length of the events array and k is less than or equal to the length of the events array, and the product of k and the events array length is of the order 10 raised to power 6. And these are the values of the start day and end day and values. These are the constraints for their values. So if we have to consider a solution, brute force solution, for example, let's say brute force solution, then for each day, for each event, there are two options, either to take it or attend it or not attend it. So let's say there are n events, then there would be 2 raised to power n options, and n here is of the order 10 raised to power 6. So 2 into 10 raised to power 6 is greater than 10 raised to power 8, which is the number of operations allowed in 1 second. So this is generally the limit. We have to make a solution that is less than this limit. So those of you who are not familiar with the concept of input size relation with time complexity of accepted solution, then I will be providing a link. So here you can see for 10 raised to power 6 input, you are only allowed these time complexity solutions, and log n, op n, op1 or log n. So we have to optimize our solution, because this solution, brute force solution, would give us TLD. So what we would be doing is, we would be, let's say for a event I, we would be considering the nearest non-overlapping. Since we are in one of the constraints, it's been told that overlapping constraint would not be allowed, overlapping events would not be allowed. Nearest non-overlapping event, and if somehow we can remember the contribution or say value of maximum value sum till this nearest non-overlapping neighbor, then we can simply access our two choices for the current. If we decide to take the current event, then we would be adding maximum value sum value to the value current event is providing, current maximum value sum plus current events value. Or if we decide not to take the event, then we would simply be continuing with one previous index or one previous events maximum value sum, and for each event under consideration we would be taking maximum of these values. So you may ask how we would be finding this nearest neighbor, and you may also ask why you are finding the nearest non-overlapping neighbor, why not the farthest. So let's consider a case. For example, let's say these are three intervals or three events given, and the sum is 2, 5, 3, 4, and since they are not overlapping, so their values will be added. So here the maximum value sum would be 2, here it would be 2 plus 3 is equal to 5, and here we will be having two choices, either to consider this neighbor, farthest neighbor, or the nearest non-overlapping neighbor. So if we go with this, then we would be getting 2 plus current value is equal to 6, and if we go with the nearest one, we would be getting 5 plus 4 is equal to 9. So the sum of the value sum is maximum in case of nearest neighbor. So that's why we are considering the nearest neighbor. Now you may also ask how we are going to find the nearest non-overlapping neighbor or non-overlapping event for our current event. So for, let's say, event I, we traverse the whole events array and find nearest non-overlapping event. It would take us one whole traverser, and if there are n events, it would be O of n square to find nearest non-overlapping events for each event. So our n here is of the order 10 raised to power 6, and again again it would be 10 raised to power 12, and 10 raised to power 8 operations are only allowed, so it would give us TLE. So we have to optimize this process also. Optimize. How we would be optimizing? Now if you carefully observe, if two intervals are non-overlapping, if let's say this is the start of A, and this is end of A, and this is start of B, and this is end of B. These are two intervals A and B. They are non-overlapping in the case the end of A is lesser than the start of B. So if it's occurring before the start of B, then we can say those are not overlapping. So how can we achieve that? We can simply sort the events array on the basis of n days, and if let's say two events are having same end, then we would be sorting them according to their start days in increasing order. So then we would be getting a sorted events array. Now you may ask how we are going to find the nearest non-overlapping event, since only start day of the previous event or the previous events that are there and the end day of the previous events and the start day of the current event under consideration matters to us. We would be storing n days of all the events, sorted events, in a array called meets. And since this would be a sorted array, since we have sorted the events array according to the n days, we can apply binary search to find a lower bound of start day of current event, and it will return the index of the lower bound, and that will be the nearest non-overlapping neighbor. So I hope I am clear, and those of you who do not know what a lower bound is, I will be providing a link to this also. And for in languages like C++, there is a direct function to find a lower bound. In Java there is no such function, so we would be implementing our own function. But in the C++ code you will find the lower bound function used. So I will be providing a link for this. Then now we would be having the nearest non overlapping interval for each event. Now depending on how many event, let's say for ith event under consideration, depending on how many events prior to this we have selected, I can be at the first place, second place, third place, or the kth place. For example, if we are considering the last event in the sorted array, then depending upon how many events we have selected before, it can be our first selection, second selection, third selection, or the kth selection. So for each event there would be k slots depending on number of event selections prior. So what we would be having is, for each index, let's say in the events array, we would be having k slots, and for while we would be considering for each element individually, we would be trying to place this event at the k slots separately and finding the maximum value sum depending upon its nearest neighbor, non-overlapping neighbor. So if you are still not clear with the solution, it will be clear in the coding part, and let's move towards the coding part. Here these comments are for your own understanding of the solution better, and the comments which are marked dry run, you can uncomment them and have a dry run of the solution, and you can understand the solution in a better way then. Anyhow, let's discuss the solution. So here we are sorting the events array based on the last day, and if the last day is same, then we are sorting it according to the first day in increasing order. Then after sorting the events array, we are storing the ends of each event, and to find the nearest known overlapping neighbor. This array we have made to find the nearest non-overlapping neighbor, since all the ends of the events now would be in the increasing order, and we can simply apply binary search to find the nearest non-overlapping neighbor that we have just discussed. So this we would be getting the position of the nearest non-overlapping neighbor. Now you may ask that here it is mentioned that the end is also inclusive, and if you found the lower bound, it may happen that the two events are having if start day of one event is equal to the end day of another event, and then it would be giving us this position. So you don't have to worry about it, as we would be considering our last logic of finding either taking the event or not taking the event, then there it would be taken care of. or you can have a dry run of the code and you will understand in a better way. So then what we would be doing is, for each of the index we would be adding the nearest neighbor, storing the nearest neighbor, so we won't have to find the nearest neighbor again and again. So now coming towards the major chunk of the program, where each event will be considered separately for the k places possible, and depending upon its nearest non-overlapping neighbor and the value of the maximum value sum stored at that neighbor, we would be making a decision whether to take this event or reject this event and continue with the previous event's maximum value sum. So what we would be doing is, you may also ask why you have taken +1 for each of the each of the dimensions of the 2D array. I have taken +1, for example, if let's say we are considering the 0th index, then there is no prior index before it, and if you are going to subtract 1 from the 0th index, it would be out of bound of the array, since index will be -1 and it would give you an error. So to take care of that, I am simply considering it, and in Java by default the array is initialized with zeros. So here we would be checking each element for the k positions available, and then we would be getting the nearest non-overlapping interval or say event from the array that we have just populated, and then we will be checking the contribution of that nearest non-overlapping interval, and we will be checking the contribution of the current event if we decide to take this event, which is nothing but the value at the second index of a particular event. And if we have not decided to take this event, we would simply be considering the previous event maximum value sum. So we would be taking maximum of these two values and storing it here, and you can have a dry run to have a much clearer understanding how we are getting the this neat contribution array populated, and at last we would be returning the last element that would be considered and its kth place as our answer, since it would be storing the maximum value of sum that would be possible following these constraints. And this is a simple binary search. Those of you who do not know what binary search is, I will also provide link for that. So thanks for watching, and the code would be available in both Java and C++. Subscribe to my channel for more such content. Thank you.